Start the recording. Welcome everybody to class number 2 of conics sections, which is the circle and the ellipse. All right, let's do this. First of all, I mentioned this yesterday, but I'll mention it again. I had a few notes yesterday, but I want to make it clear from the beginning. A circle, it says it's a point, fixed distance from a center. So you have a radius from a center point. This is nothing new. It's the same as if you were to take a string, put your finger down on the paper, and then draw a line using that string to help you. All of the points on the circle would be, of course, the same distance away from your finger, and that is the radius. Whoa, that's big. How did that get so big? That's the radius. That's nothing new, but of course, we're doing circles today, so it's nice to connect all these ideas. That radius doesn't change no matter where you are from the center. One thing that can change is, well, the distance from the center. And that's really the only thing we can change with a circle. We can change the center, or we can change, just one second. We can change where the center is, we can shift it around, and we can change the radius, or we are concerned with the radius. And the equation of a circle is given by this. So a very simple formula, actually, if you understand the pieces. Let me show you a picture of this, like I always like to do. So we have our parabola. That's not related, but you know, we had our focus and everything for our parabola. We had our directrix. I didn't show this before, but you know, that's our parabola. Our circle looks like this. Now a right, of course, has a center point. So in this case, it's at 0, 0. It's in the middle. But it also has a radius. So in this case, the radius we can see is 5. You just count from the center to the radius. If I was to move this circle around, hopefully you would notice no matter where I put it, I haven't changed the radius. The radius is still 5, but I have changed where it is. So you can see here, h has some value and k has some value. In this case, let me just make it clear. H in this particular case is 3 and k is 2 because it's been shifted 3 right and up 2. And of course, h and k are related to x and y values. So when I talk about this, that h minus k, that h is related to this distance h. When I talk about y minus k, that k is equal to that. So really, this formula, if I was to write this out, would be x minus 3 all squared plus y minus 2 all squared equals the radius squared. So it actually equals 25. And this would be the formula for this circle. So we have all the pieces. In fact, we just have 3 pieces. H, which is the shift to the right or left. K, which is the shift up or down. And then radius, which is the distance from the center. And that's all you need to know about circles. We can do everything we're going to do today about circles with just those concepts. So hopefully that's clear. And of course, if I move, if I move the circle around, the h and k move with it. So you can see that's how they relate. So let's do a couple problems with this. Tom did the first 2. Again, if you didn't watch Tom's videos on this, you're going to be a little bit behind because they really set up the topics, especially ellipses. It's a 45-minute video. It's quite long, but it's very detailed. And so you're at a bit of a disadvantage if you didn't watch it, but I'll do my best to catch you up as I always try to do. Okay, let's go to page 13 in your course notes, and let's get started. So first of all, practice 1, find the radius of the circle from the equation. It's very simple, very, very simple. Look at this. Our regular standard equation for a circle is x minus h squared plus y minus k all squared equals an r squared. In this case, what is our h? Well, we just look next to x. If it has a number there, it will give us our h value. In this case, it doesn't have anything. So we can say that our center is 0. And is there a number next to the y? There would have to be a number next to the y. There is not. So it's 0, 0. It exists at the origin. But it does clearly have a radius. So the radius here, remember this is r squared. So the number we get back is already squared. So we have r squared equals 100. Okay, let me move this over. R squared is 100, so what is R? Well, you square root it. What's the square root of 100? It's 10. I can do it in my head. I'm sure many of you can. If you can't, just stick it in a calculator. That's it. That's the whole equation. That's all we need to do. We have the radius. It's 10. Okay. Let's move on to a different one. Let's move on to the next one. You can notice, hopefully, if you look at this b, it's not in the form we want it to be, but it's very close. Remember, we need an x squared thing, a y squared thing, and an r squared. Let's just move the x over to this side. B radius will be 3. Yes, exactly. You can actually grab it straight from the formula, but it's best to make sure it's in the right form, because when we move forward with this, sometimes if we don't put it in the right form, we get confused or things go wrong. Okay? So I'm going to put it in the form first, but yes, r is 3 for sure. X squared plus y squared equals 9. That means, for the same reason, this is r squared. I don't even need to worry about the center for this question. I just wanted to note it the first time. R squared in this case is 9. So yeah, square root of both sides, r is 3. So good job, Hamza. Perfect answer. Third one I said is for homework. Let's just do it. Bring the y over to the other side for the same reason we did before. What's the radius going to be? You just look at this. What's the radius? Tell me. Don't be afraid to use the microphone. My other class talks to me like nonstop. 9. Excellent. Kevin, Hamza, excellent. Same reason. This is r squared. So if we get the square root, we get our r. You don't need to write all the workings, but as assignment 2 showed me, some of you didn't write the workings and you kind of suffered for it because you gave me the wrong answer and I couldn't use any workings to give you a part mark, so I had to give 0. So be careful about that. But this is it. I mean, this is all that's to it. And if we were to graph these, let me just show you if I wanted to graph this. Let's just take any given one of these equations. I know their center is at 0. Let's graph the one we just did. X squared plus y squared equals 81. This we can see clearly, well, I can see clearly, and hopefully you will soon too. This is clearly a radius of 9. Look. The radius is 9, and it's centered at the origin. So there's nothing special about this. We definitely have what we're saying we have. We're definitely, we definitely were giving the right radius here. So that's all there is to it. I don't want to over-explain this. It's honestly quite simple, and I think you'll agree. So let's move on. Let's find the center and the radius from the equation for this next one. Okay, we can do that. What's the center? Well, in this case, let me just be crystal clear. Center here comes from this. You'll notice it's almost the exact same as the vertex for parabolas, yeah? Why is this? Sorry, Zoom's going crazy. It's like vertex for parabolas. What we did yesterday, finding the vertex, we do the same thing for this, finding the center. But circles don't have vertexes or vertices because they don't have an endpoint. They're just a circle. So let's write it out. What's our center? It's 2 and 1. And remember, I take my sign and I flip it, but I'm still stealing it from that. Radius, my second one, nothing new. We know r squared is 25, or you should know by this point. We just did 3 examples, so r is 5. So thank you, Hamza, for that one. And one more time, I'll highlight it. This is our radius. That's r squared, so r is 5. Okay, these are nice and quick. Nothing much to them. B you can do for homework. I want to do C because there's a little extra step. What you'll notice, or what you should notice, is that this question 2C is not in regular form, or it's not in standard form for a circle. For a circle, remember, we need to have x minus h. We need to have y minus k squared, and then that should be equal to r squared. That is not the same. You notice you have a 4 in front of both. That's a bad thing. We want that 4 gone. So thankfully, that's very easy. If you want to get rid of something, you just divide both sides by that. So divide everything, every single term that we see, divide it by 4. Okay, so that gives us, that cancels the first 4. cancels the second 4. And then, of course, 121, I'm sorry I keep saying of course. It's maybe not that obvious to some of you, so I don't mean to belittle anything. 121 divided by 4 is a weird 30.25. Let's just keep the fraction. The decimal is a bit weird. Yeah, you're saying it's basically LCD? Yeah, it is, if you want to think of it that way. But essentially, we're just trying to remove the common factor. So it's better to think of it as you're taking 4 to the outside and then dividing both sides by that 4, because we need it to be going. Okay, so what was the point of this question? It was to get center, which I can read directly from this, is -1 and 0. You should now know why. I'm going to stop highlighting it after a while. Radius. Now this is a weird one, but don't let it confuse you. It is still what we said it is. This is still r squared. R squared is 121 divided by 4. So r is the square root of that. And the square root of that, well, the square root of 121 is 11. Square root of 4 is 2. If you want to write it as a decimal, it's 5.5. Okay, so you're on fire today, Hamza. Thanks for giving me the feels, as Drake would say, you know? Does he say that? All right, D. Let's do D. I want all of you to give me what the center is and the radius. It should take 1 minute, okay? The only hint I'll give is that you need to divide everything by 9 first. Okay, take 1 minute, try it. Okay, that's close enough to a minute, more or less. I'm going to divide everything by 9. Of course, keep working on it if you want. Center 0.6, oh, 0 and 6, yeah. So center, well, I can't do this yet. I need to divide everything by 9. So I get this. 64 divided by 9 is 64 over 9. You'll notice they're square numbers. We did that on purpose. Center, just change the number in front of x or behind x. There is no number, and then 6. So Hamza, you got that one. Radius, square root of 64 over 9. Square root of 64 is 8. And the square root of 9 is 3. So you got it. 8 over 3. Can't fool you. And that's how we do these. Circles are very simple. I'm going to move on. Ellipses, not so simple. Lots more to cover there. So I'm going to try to go a little bit faster. If you need to go back over this, watch the video or tell me to go back a little later. Okay, so on the next page, we need to find the equation of the circle. Again, let's write down what the equation needs to be. I want to keep reminding you. It needs to be in this form. And so there, for circles, are only 3 things we need. Well, 2 things, really. We need the center, h and k, and we need the radius. And if you have the radius, you can solve it. So we need h, and we need k. Usually they come as a group. We get them both at the same time. And then, of course, we need r or r squared, whichever one you want to figure out. R squared usually more helpful. Okay, so let's go ahead. Center is 2, 3. That means that h is 2, k is 3. If you want to remember which one is h and which is k, remember the order. H comes before k in the alphabet. X comes before y in the alphabet. So x is related to the h and y is related to the k. So that's our center. We have that. We could write our equation. And then radius 4. If radius is 4, we need to get r squared. R squared is simply 4 squared, which is 16. And so we have our 2. I'm going to change the sign. We have our r squared. and we have our k. So I'm going to fill those into our equation, and we're done. So x minus h. So x minus 2, square it. Y minus k, so y minus 3, because k is 3, so y minus 3. Square that. And then r squared is 16. Don't write 4 squared. You need to write the actual final answer. That's it. I don't really need to box that, I guess. I'll put it in a box anyway, just to be consistent. Okay, that's all we need to do. I'll do one more of these, just because the next one's a tiny bit trickier, and then we're going to move on, okay? The next one has a little bit of a twist to it. And again, if you need me to slow down or go back through anything, you got to let me know, because I'm not going to stop today otherwise. We have too much to cover. So for the next question, and you can try it yourself if you want, h is clearly -3. It's given directly by the center. K is also -5, given directly by the center. But I have this weird problem. It passes through the point 3, 0. So the first thing we're going to do, let's write the equation and just see what we can do with what we have. Well, if I was to write this equation right now, fill in what I have, what do we have? We have x minus, well, x plus 3 squared plus y plus 5 squared equals r squared, r squared, r squared. Where's r? We don't have it. So let me try to help you understand this as easily as I can. We have h, of course. We have k. We don't have r, or r squared for that matter. So we need, it's supposed to be need, we need r squared. How are we going to get it? R equals 3? No, but nice try, Ibrahim. We don't have r squared. What we do have is the point 3, 0. So the next step we're going to do, step 2, is to substitute in the point 3, 0. And by substitute in, you'll notice, or hopefully should notice, that means the x value will be 3 and the y value will be 0. If we put those values in, we'll replace the x, we'll replace the y, and the only unknown will be the r. And if we have r, we have everything. So let's go ahead and do that. So right away, I'm going to put in our number. I'll put in 3 plus 3, square that, plus, what's our y? Our y is 0. I'll write it in so we don't lose it. All that squared equals r squared. Notice we don't have any unknowns except for r now. Hamza, it looks like you're on the right track. Of course, you need to replace that. Oh, that's your final answer. Yeah, excellent. Well done. So this is 3 plus 3 is 6. 6 squared is 36. The next one is 5 squared, 25, equals r squared. We can just solve for r squared and leave it at that. It's going to be 61. That is our r squared. We have everything we need. Look, we have h, k, and r. Or h, k, and r squared. That's really all we needed. I told you that right here. We just need h, k, and r. It's the only things we need for a circle. So let's write out our equation. Hamza already did it, so you can copy his if you want, but, you know, nice to come from me. X plus 3, we already knew that. Y plus 5, we already knew that. And now we have r squared, which is 61, and we're finished. Okie doke. Hopefully that makes sense. I really hope it does. It certainly makes sense to me, but circles are basic shapes. All we can do with them is move the center around. We need to know about the center, where it is, and we need to know what the radius is. That fully describes a circle. Okay? Is there anything I can clarify before we move on to the next set of shapes, which I think is a little bit more interesting? Oh wait, we have a little bit left to do before we get to that point. Any questions on this question then? Any issues with that? All good. Okay. Nice to hear from you, Zara. Okay, so we have C and D. C is for homework because we did one just like it. And D is a challenge question. I wouldn't worry too much about it. 4, I want to show you how easy it is to get equations of circles if you know what the graph is. So find the equation. Again, exact same process. Do I even need to write it out again? Probably not, but it takes me very little time. I'll just write this out while I'm talking. This is our equation. We need three things. What are they? H, R, or R squared, and K. Can we figure those out from the graph? Well, of course we can. What's H? H is how far away we've moved in the X direction. You should be able to look directly at this graph and see how far that is. It is 3. We've moved by 3. It's been shifted from the center by 3. Am I being clear? I hope I'm being clear. So H, I'll just write that here more clearly. How much has it moved down? Well, it used to be at the 0 point in the y. How much has it moved down? Well, it's moved down 5. Down 5, minus 5. So K isn't 5, K is minus 5. So you get the idea. K is minus 5. So again, what does H mean? It's how much we move to the left and right. Shift it to the right by 3. What is K? It's how much we move up or down. So we've moved down by 5. That's it. And then finally, what's the radius? Radius here is 4. How do I know that? It's because I'm looking at this shape and I can clearly see that I'm going 1, 2, 3, 4 units over. That's my radius. If you wanted to count in another way, of course you can. Look, you can count this way. It's still 4. You can count this way. It's still 4. You can count that way. It's still 4. But I don't want to muddy up the diagram too much, so I'll delete those. So Hamza, you're saying, so 4 squared is equal to 16? Perfect. Yeah, that's the big idea here. And then you put it into the equation. Halas, we're finished, yeah? So let's write the equation. X minus H, X minus 3, plus Y minus K, Y minus negative 5, Y plus 5. That's why the sign changes. And then R is 4, so R squared must be 16. We're done. Okay. I'm going a little faster today than I normally do, but it's because I'm trying to get to the later topics. So this is the big idea. I guess I should erase that little nib there. And we're good. I would graph this on Desmos with my little tool, but I think you get the idea. I'm going to assume you get the idea. That's all you need to do for graphing if you want the equation. B is the exact same process. You should be able to get that very easily. Me, by looking at it, I can say that it's X plus 1 squared plus Y minus 3 all squared equals 4. So I didn't even write anything down. I can get it in my head. You don't need to get it in your head, but it's very fast. They're very fast questions. Finally, I'm just going to do one of these graphs because it's kind of what we just did. Graph each equation. Okay. Center. What is it? Center is 3 and 2. I'll write that. There's my center. Hello, center. How are you doing today? I'm good. How are you? I'm good. Thank you for asking. Okay. Radius. What is it? R squared is 16, so R must be 4. Just using the same concepts we've been doing all day so far. So I'll just go over by 4. 1, 2, 3, 4. I'll go left by 4. I'll go up by 4. I'll go down by 4. You don't need to go in that many directions. I just want to make it easy for me to draw. And I have a circle. Okay, so again, you don't need to write all those extra lines. You can just go from this. You can just write R equals 4. It's the pencil line that you need to draw. You just need to graph a circle. Okay, so this is the big idea. Any questions on that before I move on to what I think is way more interesting, which is the ellipse? Okay. Again, hopefully it's clear. It's clear to me. Doesn't necessarily mean anything to you, but you're only looking for the center and the radius, so it only gets so hard. Ellipses, on the other hand, have 5 things. Instead of center and radius, we have 5 things. I'm going to try to be as clear as I can We're going to need to pay very close attention to this because I'm going to be giving you a lot of information at once, but it's going to set us up for success, okay? It's going to set you up so that you're very clear on how to do this. Now, the ellipse. The ellipse is like a circle that has been stretched. Let me show you what I mean. So this is a circle. I hope you can see that clearly. The center, of course, can be moved, just like we did before. I could even move it like this if I wanted to. So I've moved it. I'll just keep it at the center. But the interesting thing about the ellipse is that instead of having the same radius all the time, we are allowed to change the stretch. We're allowed to stretch it in the x direction, stretch it in the y direction. Let me show you what I mean. I can stretch it this way. So we have a value of 6 that comes into play somewhere called an A. It's been stretched. It's almost like it has a separate radius. It's almost like the radius in this direction is different from the radius in this direction, right? They have two different radii or radiuses, which is the big idea behind ellipses, really. I can also stretch it in this direction, okay? So we can stretch it, whatever way we like. Sometimes the ellipse will be more stretched this way. Sometimes it'll be more stretched that way. The equations will tell us which one's which. But this is the big idea, and I hope it makes sense to you. So let's just say that this was our equation. The things that matter on this ellipse are, I'll just change one thing. I'll make this stretch better. Okay, let's just say we have this. The important pieces of an ellipse, I'll show you right here on the diagram, are this point, well, of course, the center. The center is very important. The end points here, which are called vertices, that's along what we call the major axis. It's the longest axis. And we'll see that relates to what we call the A value. We also have a minor axis, which is the shorter distance from the center. We call those points, those endpoints, co-vertices. So we have a vertex, two vertexes, which are called vertices. We have two co-vertices, which are the other points. And then do you remember one point that we had yesterday with the parabola? Remember we had the curve, we had the directrix going underneath maybe, and then we had a point inside the curve, which was called the focus. And so the ellipse also has a focus. I'll just say it's roughly about here. I don't know exactly, but it's pretty close. All right, this is how we describe ellipses. Now there's obviously other letters going on here, but these are the important points. So hopefully that makes a bit of sense. Again, in summary, the ellipse is just a stretched circle. We have what's called the major axis, which has vertices on it. We have a shorter minor axis, which has co-vertices on it. And then we have a foci, or two focus points called a foci or foci, which are also on the major or longest axis. So now that I've talked your ear off, let me do some work in the notes so we can connect all these ideas. So these are the big ideas. Follow me. Major axis, the longest axis. We always call it A, okay? It's always related to what we call the A value, and I'll come back to that. The endpoints are called vertices, and the length is 2A. All that means is if this was A, then of course the total length is 2 of those. The second step, the minor axis, shorter axis. Okay, in this case, this up like this is B and B. The endpoints are called co-vertices, and the length is 2B. Okay. Something that we'll also need is the values A, B, and C, C being the distance from center to focus, and we can say that this is our equation for getting that. I'm not going to talk any more yet. I'm not going to talk very much more. We're going to do an example, and it'll become clear what I'm saying, okay? But the important thing is I've covered the basic setup. So this is what the formula looks like. Okay, let me slow down and ask you to pay close attention to this part. This equation has an A value underneath the X. That means that that A would be the bigger number when compared to B, A and B. And because the A is under the X value, it means it's stretched in the X direction. That means that if the bigger number on bottom is with the X, we stretch it in the X direction. That should make sense because it's affecting the X. The other thing that might happen, the other equation here, I want to write a different one because this is how you normally see it. It looks almost exactly the same, almost identical, except the A is under the Y. Now, you might not know what those things mean yet. You might not remember. But I want you to know that we're going to be using that a lot. So let me re-explain. In this case, this equation is for an ellipse that we can say has been stretched in the Y direction. Because that number there, let me give you an example. Okay, let me give you a side note here. Let's just say we had x squared over 16 plus y squared over 4 equals 1. Okay, just follow me here. The bigger number here is 16. That means that the ellipse will look like it's stretched in the x direction. That's all I'm talking about. That means that the x is the major axis. If this was instead written like this, notice the only difference is the 16 is now under the y. Notice the bigger number is under the y value, which means it will look like it's stretched in the y direction. So it looks like this. That is the big difference. No matter what variable that number is under, we always call it A. Okay? A relates to what we call a major axis. I'm going to explain that more in a second with an actual example. And finally, I've said here, A is always the bigger value. And finally, this is the last thing I'll mention before I do some examples. E is the eccentricity. What it means is how weird the circle is if we compare it to how weird the ellipse is if we compare it to a circle. Stop talking for a second. Just give you time to catch your thoughts. Okay? So let me summarize the most important pieces of the ellipse. 1, center. 2, vertices. You get them by knowing the center and adding or subtracting A. Third thing, co-vertices. You get them by having the center and adding or subtracting B. 4, foci. You get them by having the center and adding or subtracting C. And we have a formula for C. And 5, eccentricity. You get it by dividing C by A. Again, from a formula. We'll follow that recipe the entire day. Okay? So Tom did all these examples. I'm going to start with example 3. I'm just going to briefly, very quickly write down those 5 steps that I just said. You might even remember them. But there's 5 things that are extremely important. And if you keep those 5 things in mind, I guarantee you can get full marks on this type of question. First thing, what was it? What was it? Same as the circle, center. And center is the H and K values. Very important. Second thing you need is the vertices, the vertexes. You get them by adding A to the center. Co-vertices, you get them by adding B to the center. Foci, you get them by adding C to the center. You'll notice that C squared is A squared minus B squared. That's just a formula we use. And finally, eccentricity, or how weird this is this. Now I know that is a lot of information for you. Totally aware of that. First of all, you should have already seen it with Tom. So if you didn't see it already, then I can understand why it's overwhelming. But I have everything laid out now, and we can work through the problems together. And I think you'll see that these are very nice to do. They're actually not very difficult. I wouldn't say they're fun, but at least it has a very logical process. Okay, so let's go ahead and do this. Coordinates of the center, find the coordinates of the center. the vertices, and the foci determine the eccentricity of the ellipse, okay? The 5 things that I listed. I changed the formula, or I changed the equation so that we have a better group of numbers. So first things first, what do I do if it's not in the form that I want it to be? I need to make sure that the right side is 1. If you look back earlier, the right side of this equation always got to be 1. So first thing we do is we divide this equation by 36. Divide everything by 36, that'll make the right side 1, and it'll simplify the rest. So just to be clear, divide this by 36, divide this by 36, divide this by 36. What do I get? What's 4 divided by 36? It's 1 over 9. So that's the same as x squared over 9. What's y divided by 36? The same thing as 1 over 4. And then 36 divided by 36 is 1. So this is where the fun starts. Now that we have a formula that looks like an ellipse, we can start. Now, I know this is an ellipse because it has a squared on both of these values, and it has 2 different numbers on bottom. If they were the same number on bottom, it would basically be a circle, okay? Now, I have my first question for you. I know you can handle this. Which number on bottom is bigger? 9 or 4? 9, yeah. So that 9, the bigger one, is always a squared. A squared. So you said it's a squared. Think of it like before we were given r squared. This is like that, but it's kind of like a radius for ellipses. It's almost like got 2 radiuses. So if that's the case, then a is 3. That's the bigger one. It goes under the x. I already know what this ellipse is going to look like. I know that it's going to be stretched in the x direction because the a is under that x value. Now, speaking of what it looks like, I know some of you don't love making sketches. I hope you'll learn to love it because you will have a much easier life with these topics if you sketch, okay? Yeah, although you don't like sketching, well, just make a basic sketch. You don't need to worry. It doesn't need to be perfect. It just needs to be accurate with the numbers. So first things first, what's the center? Center is 0, 0. I know that because I'm looking at this, and there are no h or k. So the center is at, oops, the center is in the middle of this, 0, 0. Now, that's all I can do so far, although I can get the vertices because I have a. So the vertices come from a. How you do this, you take the center and you go, if it's for x in this case, you'll go 3 to the right and 3 to the left. Because in this case, I have a equals 3. That's how far I go from the center. So Abdo, even you with your basic drawing skills, if that's what you're saying to me, you can do this. Just go 1, 2, 3 to the left. 1, 2, 3 to the right. 3 to the left, 3 to the right. 3 to the right, and the left and the right. You did 3, 3. I think you mean 3 and negative 3. So right here and right here. So my vertices, if I read off my sketch, I can see that my first vertex is 3, 0. I hope you can see that. And my second vertex is negative 3, 0. Because this is 3, 0. This is negative 3, 0. Okay. I hope that you can see that. I'm going to erase it though because it'll take up space, but I just wanted to write it so you can see that. That's where they came from. Now, I got A. I'm always going to go from A and then get B and then get C and then get E. So watch this. Hopefully you're following me so far. What's B squared? B squared is the other value. 4. Smaller one. B is always the smaller one. So it's 4. That means B is 2. Good job, Abdo. And now that will give us my co-vertices. What are my co-vertices? Well, I do the same thing, but careful. The co-vertices are not along the major axis, they're along the vertical or the minor axis. So I go up 2, 1, 2, and down 2, 1, 2 from the center. So that gives me this. Now I have the shape that I expected. I knew it was going to be stretched in the x direction because that's where A is, but now I have a good sketch and I can start filling this in. It doesn't need to be perfect, but some students draw a diamond, which is totally not right. So just don't draw a diamond, please. At least try to make it look like a squished circle. Some students do this, and I'm just like, have you even been listening this entire time? It's an ellipse. What are the co-vertices? I can read it directly off of my sketch here. I can see that my first one is 0 and 2. My second one is 0 and -2. Because I made the sketch, it's very simple. If I hadn't made the sketch, I would have had a harder time keeping track of this. If you're wondering where the numbers come from, let me just zoom in on this for a second. I know you might still be reading. This is my B, yeah, from the center. And this is also a distance of B. And then this distance here was A, just like this distance was A. It's a little bit messy there, but that's where the numbers are coming from. So you add and subtract A from the center, and you add and subtract B from the center. It's X or Y depending on what the case is that you have. How did that happen? I'm very sorry. I'm very sorry. I don't know how that happened. Okay. There we go. So my sketch is a little bit ugly, but it's detailed now. And just to add some more detail, vertex, vertex. CV, CV, co-vertex, co-vertex. What am I missing? Looking at my cheat sheet, I have center, vertices, and co-vertices. I need my foci. So I need to start with c squared. C squared is easy. C squared is a squared minus b squared. That's a rule. It never changes. It will always be that. And then look, a squared I already have, and b squared I already have. In fact, they're actually even given in the original equation up here. So I can steal those numbers. So 9 minus 4. What's that? That's kind of ugly. It's going to come out to root 5, isn't it? It's okay. Not 5. Careful. That c squared is 5. We want root 5. Yeah. If you want that as a decimal, you can get it as a decimal. It's okay, 2.24. Depending on what we're doing, sometimes it's easier one or the other. That gives us the foci, or the two focal points. Remember, the foci is for the major axis. Okay, the vertices are on the major axis, in this case x. The focus points are also on the major axis, in this case x. So we take the center, add c. Well, that's going to be pretty easy, honestly. It's just go right by c and left by c. So root 5 and 0, negative root 5 and 0. Those are my focal points. Those are my foci. So I actually have almost everything I need now. I have my vertices, co-vertices, foci. Foci or foci, they both are, it depends on how you pronounce it. Where you're from in the world changes the pronunciation, but they mean the same thing. It's just the plural of focus. One focus, two foci. One vertex, two vertices. One co-vertex, two co-vertices. Now we need the eccentricity. That's simple. The eccentricity is always c over a. So just take your c value, divide it by a. C is root 5, a is 3. I'm done. You can also call it, you know, if you wanted to give me the actual decimal value, it would be 0.745. So depending on what number you get back, honestly, it doesn't really matter what number you get back, but the closer it is to 1, the more like a circle it is. The further away it is from 1, the less like a circle it is. So the smaller that number, the more squished it is, or the more stretched it is. Okay, so let me summarize. I'm going to read you what we did. And you can take 1 minute to yourself if you don't want to listen to me, but it's very important that you know what happened. So what we did first, we got it into the proper form. Then I looked at it and say, which one's A, which one's B? Well, the bigger number on bottom is A, and it's attached to the X, which means it must stretch the circle in the X direction. That's my major axis. B is the smaller one. It stretches it a little bit, but not as much. That's the minor axis. From A, we get vertices. You just add it to the center. From B, we get covertices. You also add it to the center, but in the other direction. And from C, we get foci, which you also add to the center. You add all those things to the center. Once you're done with that, you get eccentricity, and it tells you how squishy this ellipse is. Okay, and that's all. I know it's 5 steps, but they're an important 5 steps that we're going to see over and over and over again. Any questions? Okay, I'll take it as a no. So Tom did these sketching examples. He also did example 3. So I'll just go ahead and do the summary. It's basically what I've been saying, but in text form. Of course, we have our equations here. We have the center is HK. They are long, Hamza, they are long, but they get faster. You'll find that they actually don't take very long to do because it's the exact same steps every time. So the more practice you get, the faster it goes. And it really does go fast. We'll do 2 or 3 more of these. You'll see it's the same process. So a squared is always the biggest denominator. The whichever one, so for example, if x is above a, the major axis is horizontal. If y is above a, the major axis is vertical. And finally, the foci are related to the c value. C tells you how far along to move on the major axis. Okay, so let me summarize it even better, and then we'll do some examples. Vertices, you find the center point, and you add and subtract a. For covertices, you find the center point, you add or subtract b. For foci, you have the center point, you add or subtract c. Vertices are related to the major or bigger axis. Covertices are related to the minor or smaller axis. Foci is also related to the major. So you see that these are actually kind of connected. Okay? From B, what do we get? Sorry, what was the question? Are you guys talking to me or are you talking to each other? I can't tell. For B? B? I'm just going to go ahead and move on because I don't know what your question is and you're not writing it again. Okay. Practice 1. Let's do this. Okay, let me get inside my brain. Yeah, the smallest on bottom is B. So let me show you how I work through this. I'm going to go faster this time. Find the coordinates of the vertices. In other words, find the vertex and the co-vertex, the foci of each ellipse. And I'm also going to ask you just get E as well, the eccentricity. So right away, when I look at this question, I see the number on bottom is 4 here, and it's actually 1 here. That means that the ellipse will be stretched in the x direction. So it'll look like this. That also means that A is 4. So before I do anything, let me just write down my center. I notice the center is 0, 0. A here, the bigger one on bottom, A squared, is 4. That means that A is 2. I can get my vertices from this. I'm going to draw a sketch, though, because otherwise I very easily lose track of things. Okay, center at 0, 0. Major axis is in this direction, and I go over by 2. 1, 2, 1, 2. That's my vertices. What are they? They are 2, 0, and negative 2, 0. Okay, that's it for vertices. Moving on to covertices. B squared is the smaller of the two. It's a 1. What's the square root of 1? 1. So that gives us covertices. The minor axis in this case is the small stretch upwards, not over, but up. So we go up and down by 1. That means our covertices are right here. And so it's starting to take shape. I knew it was going to look like this. Now I can draw it. There's this little baby ellipse. Okay. It's just a small little baby ellipse. And now from that sketch, I'll get that it's 0 and 1 and 0 and -1, which is excellent. Abdo, you got that. Moving on, I'm going to get C. C squared is a squared minus b squared. And notice this isn't Pythagoras. This is minus. A squared minus b squared, not a squared plus b squared. So you can always use that formula as a reference. C squared then, and I do care about c squared. I don't really care about c is, actually, sorry. I'm sorry to keep erasing things. C squared is 4 minus 1. That means that c squared is 3, so root 3. If you want to write it as a decimal, which is sometimes helpful for sketching, 1.73. Okay, we have C. What does C give us? C gives us the foci, or foci, depending on how you want to say it. I'm going to move the foci to the side, actually, because I ran out of space. Foci, from the center, root 3 and 0. Nope, a nice try. The foci, you go from 0 along the major axis and add the foci. So you go over root 3 and back root 3. In other words, add root 3 and subtract root 3. So root 3 and 0. Good job, Hamza. Negative root 3 and 0. Those are our foci. I should have really drawn it. Root 3 is 1.7, so over here. You don't need to sketch it if you don't want to. I think it would be a really bad idea not to sketch it, but you don't need to sketch it unless it asks for a graph, which it will eventually. So why not just practice sketching? I mean, why not? And finally, I'll just give the eccentricity because I added that as a question just in case. Eccentricity is C over A. C is root 3. A is 2. So that's the answer. In other words, what's root 3 over 2? 0.866. So it's not quite a circle. That number's not 1. It's a little bit squished. It's not the best circle in the world. It's a little bit squat down or squished down. So these are our vertices. These are our co-vertices. This is our foci. That's our eccentricity because I just asked. It wasn't in the original question. I just added it there. So you have a preparation. Okay? Oh, Ibrahim, yeah, I saw root 3 and 0 now. I see what you meant. I thought you meant that 1 was root 3, 1 was 0. I think I might have told you that you were wrong, but you were right. Good job. Do you see how I followed the same steps? Do you see that it isn't such a big headache? It's just long. I don't need to, I'm just explaining every single step. Hopefully it makes sense. Let's go ahead and do another one. We still got quite a bit of time left. So yeah, I want to make, yeah, that's what I'm doing. Well, let's go through the same steps. Just practice, practice, practice. Talking about practice. Okay, center. Center for this one. 0, 0. Which number is the bigger one on bottom? I know you can answer that question. Is it 100 or is it 64? Of course it's 100. That's related to the x, so it should be stretched in the x direction. I know that before I even start. Let me write down what that is. That's a squared, the bigger one. Square root of that is 10. I'm going to go ahead and do my b and c because I just like to do all that first. I don't know why. I just find it easier. B squared is 64. Square root of that is 8. Let's go ahead and get C as well. Sorry, to plug this in. It's always that time of day that my laptop starts dying. Okay, C squared is 100 minus 64, which means C. One second. Can you still hear me? My laptop's telling me that it can't, but I think you probably can. Yeah? Okay. don't listen to technology. It's only trying to confuse you. So that's Route 36. Get your kicks on Route 36. All right, I've got A, B, and C. They give me vertices, covertices, and foci, respectively. I'm going to write it a little differently because some students prefer it. Actually, I'm not going to do anything yet. I got to make a sketch because otherwise I'm going to confuse myself. So let me see. The center's at 0. The major axis is along the x direction. I need to go over by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And go up by 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now, for the fun part, those are my vertices. This is my co-vertices. And my foci, which will be left and right by 6, finally a reasonable number for foci. I'll go left and right by 6. 6, 1, 2, 3, 4, 5, 6. Those are my foci. I didn't need to write them down, but I asked for them, so why not sketch them? And now let me see if I can cheat. Come on, ellipse. Bah. I did my best. I'll do it the old-fashioned way. So ellipse. Ellipse. I always have problems with that bottom corner there, but it's good enough. Okay, let me write in my vertices. I can take it directly from the graph. You're saying B is 0, 8, 0, negative 8, perfect. Foci is negative 6, 0, and 6, 0, perfect. So we just need vertices. But you have 10, yeah, done. So Hamza, you got it right. I'm going to write this, V, 10 and 0. So I can basically just write out Hamza's answers now, because he got it. CV for co-vertices is in the y direction, so 0, 8, 0, negative 8. Foci, 6, 0, negative 6, 0. And finally, the eccentricity, or how weird the shape is, 6 over 10, or in other words, 0.6. It's C over A, just in case you forgot. Oh man, I'm running out of steam. I've been at this for like 4 hours. Okay. These are your answers. Thanks, Hamza. Maybe you should just do the rest of them for me. I don't know. We'll see. They might get different. Okay. We have our pieces. We have our coordinates. We've only done X style at the moment. We have not done Y style where we pull it in the Y direction. And that's okay. We're going to do one now. I just want to show you, if you were to do C, because this is something that you could do for homework, should do for homework, should always do all the practice for homework before an assignment or a test. It's not in the form we want because the right side is not equal to 1. So I'll just give you a hint. You divide it by 144 first. So what you should get here, if you wanted to try this question, you would start with this. You might be wondering, Mr. Scott, you're crazy. Why would I want to do more work? I want to do the least amount of possible work because it's Ramadan and I'm hangry because I haven't eaten for forever and I'm just busy. What are you doing to me? I got enough stuff on my mind. And I say, if you want to do well in math, you have to practice. Sorry, just got to do it. If you want to get good at anything, you got to practice, especially math. So the practice is there for you. If you want it, you do it, and you'll get better. Okay, let's do this. D. Let's change the form first. Let's force it into the form that we want. So expand it. We get y squared equals 16 minus 8x. I just open the brackets. Now I need to move the x stuff to the left side. This is, of course, nothing new. You can handle this. Now this is an ellipse, and ellipses have a value of 1 on the right side. So we've got to divide this by 16. Divide it by whatever's on the right side, it'll cancel everything else. What we'll get now is x squared over 2, y squared over 16, and 1. So this is our new equation. Now it matches the form that we need it to be in. We need it to be x squared stuff over a value, y squared stuff over a value, but it needed to be equal to 1 on the right side. That was the most important thing. So what do we have here? Let's see. Where is our a? Which one is a? Or a squared? 2 or 16? Or in other words, which one's bigger? Yeah, 16. Okay. This is our a squared. That means that this other one, the smaller one, must be our b squared. That is not the same as it was before. A is always the biggest one. That means this is stretched this way, which I told you was going to be anyways. But now we can confirm it definitely is stretched vertically. So I'll just make a little sketch. It'll look like this in the end. You'll notice that my sketches have all been correct so far, yeah? Stretch that way, stretch that way. Well, I'm pretty much a genius, just saying. Not really. I did these questions ahead of time. So let's see. A squared is 16. That means a is 4. B squared is 2. That means b must just be a annoying root 2. C squared is going to be a squared, 16, minus b squared, 2. That means that it's 16 minus 2, which is 14, square root of that, root 14. I'm not going through every step anymore because it's not necessary. So good job, Abdul. You're saying 0 root 2 and 0 negative root 2. Now that's wrong. How the mighty have fallen. Let's make a sketch. So, center is at 0, 0. The major axis is under the y squared. So we are going up this time by 4. 1, 2, 3, 4, and down. 1, 2, 3, 4. I think that's your problem, Hamza. Your minor axis is in the other direction. Okay, up by 4, down by 4. So right now I can get my vertices. My vertices are 0 and 4, 0 and negative 4. I'm so tired. Okay, co-vertices, let's write it in. What's root 2? Root 2 is 1.414. So let's go over by, let's give it some space, 1, 2, and we need to go about 1.5. 1.4 is like almost 1.5. The sketch doesn't need to be perfect, but 1.5 is about there and there. And again, the sketch helps you understand what's going on, so don't be afraid to draw the sketch. Now that you have the vertices in both directions, you can make a sketch. Doesn't need to be perfect, but it should be at least sort of accurate. You know, do your best. CV, co-vertices, these are in the y direction, so I should have a 0 and then a root 2. Wait a second. They're in the x direction. I almost did a Hamza there. I almost pulled a Hamza. So root 2, 0, negative root 2, 0. Now I've got what I wanted. My foci are, are they in the x direction or the y direction? They are always in the direction of the major axis, the longest axis. So what is root 14? Root 14 on my calculator, I'm getting that it's apparently around 3.74. About 3 3/4. So 1, 2, 3 and a bit. 1, 2, 3 and a bit. It's about there. You don't need to sketch it, but I recommend that you do. That's in the y direction. You have to juggle a lot of ideas when you're doing this, so please, please, please get the practice. Don't wait. You know, if you have free time today, tomorrow, do this practice, because tomorrow we're doing another topic, a different topic. You're not going to remember these steps unless you practice it. So tomorrow we do hyperbolas, which is similar but different, and you don't want both of those things jumbling up in your head, right? Hamza, why do you feel bad? Ahmed, we have a WhatsApp group. Yeah, it's all right, Hamza. We can't all be perfect. So Hamid, what I'd like you to do is send an email to me, just reminding me to send you the link, and I'll send it to you. We already have a WhatsApp group. So that's scott.scan. I'll just write it. So that's my email. Send me an email and say, WhatsApp group, please. And I'll send you the link. But we're done with this question. I don't know what happened there? What is going on with my computer today? Maybe it's a sign that I should give up, but I will never give up. Okay, vertices, co-vertices, foci, and eccentricity. I'm not giving up. I can't give up. We got 20 minutes left, and I need every single minute. I went 1 minute late in my other class because we've got to finish it. Like, we just don't have enough time in the term. If I go and follow my plan every single day till the end of semester, I have no time free. It goes right till the last day. I can't even take a sick day or a personal day, you know? I don't have the luxury of that. So we got to keep moving. But nice try. You can hear me, right? Yeah, I can see the mic. Okay. So practice 2. The first one you'll do for homework, but in this case, we need to sketch each ellipse from the given equation. A little break. This one's a little easier. Let me talk you through it. First of all, where's the center? You should know the center, in this case, 0, 0. I've just got 2 sections of them, but it's 4 hours a day. So it's, well, 3 hours a day, but it's intense. I started teaching today about 2 o'clock, but I haven't stopped. So it's, yeah. Okay, center 0, 0. Get a squared. It's the bigger one. A squared is 81. That means a is 9. B squared, 49. B is, what's 49? It's 7 squared. You can just use your calculator. Just to make it super clear, this is going to be pulled in the y direction. That's our major axis. This is going to be pulled in the x direction. That's our minor axis. And then C, finally, C squared, 81 minus 49. It's a squared minus b squared. So 81 minus 49 is 32. So root 32, also known as 4 root 2. I'm going through this fast because we've done most of these steps already. Okay, why did I get those? It's because it will allow me to get the sketch. And so it needs me to sketch this, yeah? Sketch each ellipse. I technically don't even need to write down the vertices now. I could just sketch it, but I'm going to write them down. So the center, stretch in the y direction. Go up 9, down 9. That's right there and right here. If you don't have a printer, that's okay. But I've told you, you need to have at least a notebook, and preferably would be better if you had graph paper, okay? Because I told you ahead of time that it's good to have it, and now you see why. You need to be able to do this stuff. Okay, and then left and right by 7. So 7 is what, right here and right here. That's enough to sketch the ellipse. Just do your best. Make sure it's curved, not a diamond. Do not want to see diamonds. But it should be at least sort of like an egg. If it looks more like an egg than a diamond, you know, you're on the right track. We need to give the vertices and the foci and everything like that. The foci are 4 root 2, so go up by 5.5 or so. 1, 2, 3, 4, 5 and a bit. Down 1, 2, 3, 4, 5 and a bit. That's our foci, whatever you want to call it. Finally, vertices. What are my vertices? I can just read it. It's 0, 9, 0, negative 9. Co-vertices. 7 and 0, negative 7 and 0. And foci, or focal points, 0, 4 root 2, 0, negative 4 root 2. And if you don't have time or you can't write as fast as me, just, take a picture of this and fill out the notes for yourself later. The important thing is the steps. And I'm following the same steps every time. Remember the 5 pieces? Center, vertex, found from A, co-vertex, found from B, foci, found from C, and then eccentricity if I need it. In this case, I don't need it, so I'm not going to write it down. Man, I'm tired. Everyone can hear me okay, right? Yeah, okay, good. Good. Let's keep going. We got 17 minutes left. I'm going to make it. I'm totally not going to pass out or anything. All right. Homework is the next one. The only suggestion I'll give you is if you try it, make sure you divide it by 144 first. That will give, and I'll give this to you. I feel like I already gave you a similar one. 16, y squared over 4, and 1. Okay? And it should look like this. You should know why, because this is attached to the x. Okay, we're almost done. We have 3 questions left. Are you excited? Are you excited? Are you excited? I'm excited. The reason I'm excited is because we should have enough basis now of understanding how this works to be able to take it from a graph and make the equation. So you should be able to look at the graph and say, okay, I see the center, I see the vertices, and I see the focus points, so I should be able to make the equation myself. You probably can't, but you will be able to, because I'm going to teach you. Okay, let's move on. We got 2 more pages, 3 more questions. Page 22. Find the equation of the ellipse from the given information. Just as a reminder, what does an equation of ellipse look like? It looks like this. It's okay. And what we need to figure out is which one is on bottom here for each one. The bigger number will go with the major axis. So let me try to help you through this. First of all, we need to figure out the center. Where's the center? Well, in this case, the center is given. It's 5, negative 1. I hope you agree. I'm going to scooch this down a little bit. We can see the center. I'm looking at it. It went over 5, down 1. The x is over 5, and the y is down 1. So from that, I can get my my h and my k. You might remember those. Remember? Okay?
بس ما عندك مشكلة.
Okay, so A. What is A? Can someone tell me what A needs to be? Let's just zoom in on this a little bit. A is the distance from the center to the major axis, or the vertex. What's A going to be? I know you can do it. I believe in you. 4. Thank you, Zara. 1, 2, 3, 4. A must be 4. I'll write that here. If A is 4, then A squared is 16. And by the way, I know it's with the x now because I know it's been stretched in the x direction. I can see it. By a similar logic, we can figure out what B is. B is going to be 1 because it's the distance from the center to the minor axis, or the distance from the center to the co-vertex, co-vertices. So if that's 1, B squared, also 1. We have everything we need now. So Hamza, you're saying x minus 5 all squared all over 16 plus y plus 1 all squared is the equation. You're right, sir. Maybe you're back on a hot streak. So let's write the equation. X minus the h, so x minus 5. Square that. A squared we know is 16. I'll write it in blue if you need to. Plus y minus k. That's y minus minus 1. So plus 1. That's why it changes sign. Over, we know what b squared is. It's 1. Well, I don't really need that 1. That's why Hamza didn't write it. If something's over 1, it's just itself. So I'm going to just, I'll keep that there so that you see it, but I want to be very clear. It's actually this. There's no need to write that 1. It's kind of a waste of time. Anything divided by 1 is itself. So this is really our final answer. So good job, Hansa. You nailed that one. Anyone else have any questions on that? I know I've just been throwing things at you today, but it's just the nature of this section. There's so much to cover. I want to get as many examples done as I can. You can always watch the videos again. You need any clarification? We'll take it as a no. I was pointing at you. I don't know if you saw it. Okay. The second question, B. Sorry, this scheme is not that long compared to the last one. No, it's not. It has a lot of pages, but you'll notice it's mostly one big idea approached from different ways. Remember, it's only 4 things. It's just parabolas, circles, ellipses, and hyperbolas. And then we just do a little bit more extra work with them, seeing what the differences are. But mainly it's shorter, or at least less different ideas, just bigger ideas. Okay, B we're skipping. You can notice that I put a giant X through it. It's way too hard. If you want to try it as a challenge, you can, but I think it shouldn't have ever been put in there. The next 2 are fine. Tom actually did some like this, but I'll do it with you. First things first, change this word to vertex. Change this word to focus. Okay, I'm going to try to lead you through this. And again, we're trying to find the equation, which means we need to fill out every piece of this. And we don't know what's on bottom yet because we don't have a picture. So if you're Abda and you're scared of sketches, you might have a very difficult time with this one. So let me, let me write it out for you and see what we have. First of all, center. What is the center? Let me write it out. It's 0 and 3. So I know that H is 0, K is 3. If I need it later, I will use it. I will need it later, of course. It's going to be these. Okay, now I need to figure out my vertex information. Well, it's been given. I'm going to make a sketch so we can see clearly what's going on. Center at 0, 3. So let's put that down, okay? 1, 2, 3. It's my center. My vertex is at 12, 3. So right 12 up 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm trying to keep them equally spaced, so I kind of ran out of space there. That's okay. Vertex is there. Okay, that's my vertex. Focus is -4, 3. So go left 4 and up 3. 1, 2, 3, 4, and up 3. That's my focus. Let me be crystal clear here. Focus, center, vertex. And that's it. That's all we have. How are we going to get A and B from this? Well, let me try to be as clear as I can. The center, done. We have H and K. Vertex is normally found from A, which means that A can be also found from the vertex. It's the distance from the center to the vertex. So A is this. A is that distance. What is that distance? How far away from the center was the vertex? 12. That's our answer. And secondary, can we find B? No, we can't because we have no vertical information. But we can figure out C. So let me just show you, I'll jump ahead. This distance, C is 4. We don't care about negatives, it's all distances, okay? So we have C is 4. So let me write a few things on the page and it'll become clear once I go back through it, okay? Just bear with me for a second. I'll try to clarify. First step here, we need to figure out our A information. So A is 12, which means A squared is 144. And by the way, that's going to go under X. because we can see the vertex and the foci are in the x direction. So we've kind of solved that puzzle. A squared here. Next, I need to use C. And the reason I need to use C is if I know C, I can get B. Remember how we get C by using A squared and B squared? Well, if we know A and C, we can get B. So just trust me now. Trust in me. I'll get you through. So we know that C squared is, first of all, we know that C is 4, which means that C squared is 16. Okay, that's the first thing. But then look, C squared is A squared minus B squared. Hamza, you got it. Good job. A squared minus B squared. We're looking for B squared. So let's write it out. B squared is C squared. Oops. B squared is A squared minus C squared. Sorry, I'm starting to like lose my mind. I'm saying just letters over and over again. And then if you work that out, B squared is 144 minus 16. Or in other words, B squared is 128. So again, I know this is a lot. I know it seems like a lot, but you have to do the practice. You are expected to be able to do these questions. This particular one is one of the harder ones in the entire course. Okay, so just keep at it, keep practicing. You will be okay. And then now, look, I have A squared. I also have B squared. So the question is actually done. Hamza proved that. His answer has a 128 in it, and his answer has a 144. That's B squared and A squared. So let's fill it in. X minus H, so minus 0, don't put anything. Over A squared. What's A squared? 144. Plus Y minus K, so Y minus 3. K is 3. Square it. Over B squared. B squared is 128. And then that's equal to 1. So really, it's kind of like 4 big steps. The numbers are, you know, it's not a recipe. I'm just trying to remind you where I did what. And that's the big idea here. All right, we have one more to do after this, which is actually an easier question. This is a tricky one. Abdo, what's your, did you have a question there? Oh man, I'm standing up too long. You just said, okay, good. Let's finish. We got 4 minutes. I think I can do it. I think I can do it. Let me try to go as fast as I can without losing everybody. Okay, first things first, center, 2, 1. Center is -2 and 1. Means H is -2, K is 1. All right, I might as well continue to highlight them. I'm going to make a sketch. I've got my center on the sketch, a vertex on the sketch, and then do you remember when we did circles, passes through this point? We're going to do the same thing again. We're going to set up our equation as best we can. We're going to put in that point that's going to solve for our unknown value. So let's put our center on the graph. Over by 2, up by 1, that's my center. Vertex, left by 2, up by 5. So 1, 2, 3, 4, 5. My vertex. That means that must be the major axis in the y direction. I know that already. So I already know what A is. A must be, what's that distance? 1, 2, 3, 4. A must be 4. Okay? So from that, I know that A is 4. That means that A squared must be 16. Now, I don't know B. Just bear with me for a second. Try not to jump ship like a few of you are already leaving. X plus 3 squared. I know this is stretched in the y direction, so under this is going to be B squared, and I don't know B squared. Plus y. Y minus what? Y minus k, and k is 1. Over A squared. A squared is 16. Equals 1. Now, I have x, y, and b are all unknowns, but if I substitute in 0 and 1, it will work out for me. This is x and this is y. I can do this in 2 minutes. I got it. I got it. I got it. I got it. I got this. Okay, sub in 0 and 1. X equals 0 plus 2. Square that over b squared. We need to be looking for b squared. Plus y minus 1. Y here is 1. I end up with 1 minus 1. I forgot to square up here. Squared over 16 equals 1. Hey, look at that. 1 minus 1 cancels. It becomes 0, so that all becomes 0. That whole term cancels, okay? What am I left with? I'm left with 0 plus 2, which is 2, all squared, which is 4. That means that 4 over b squared is 1, which gives us b squared equals 4. I knew I could do it. I'm going to finish right on time. Let me write the equation. Final answer, x plus 2, all squared, over 4 plus y minus 1, all squared, over 16 equals 1. And we're done. Okay, man, I'm tired. All right, I hope that it was clear. These topics, I wouldn't call them easy, but I also wouldn't call them difficult. They take some time, and especially these last two questions. If you don't understand how ellipses work and what all these letters mean, you don't have a chance. And so please, if you have any issues, watch Tom's videos, re-watch this class, and then do as many practice problems as you humanly can, okay? Do as many as you possibly can. Besides that, if there's no more questions, I'm going to go spend some time with my family and probably eat a million pizzas. Okay. The next assignment, yeah, it'll probably be a shorter assignment. We'll see, okay? Because we do have a test on Monday, so we'll see. All right, I'm going to stop the recording. Thanks, everybody. See you around next time.